Now that we've taken a look at the mounting phase of our component, after our component has been mounted onto the DOM, any future updates, either to the props, to the state, or us manually forcing an update on our component, will cause our component to go into the updating phase. So what is the updating phase and what triggers updates? Well, if, for example, inside of our app.js, we're passing in the text value off of this.state, right, into our lifecycle methods, which for us is this string where whenever we click the button, we just append underscore hello to that string. We just make it longer and longer, right, which we can see right here. Now, every time we update and click this and update our state, and this new state value gets passed into our lifecycle component, our lifecycle component goes into the updating phase and it's like, oh, I got new props. I should probably re-render my component. Not remount though. Our component is already mounted. It doesn't need to go through mounting again. It doesn't need to be destroyed because React doesn't want to create new elements for it. Doing that is actually very costly on the browser. But selectively changing pieces of the HTML inside of our component is way easier because all it needs to change is this.props.text. It doesn't need to change the h3. It doesn't need to change the div. So React's like, oh, okay, I'm just going to update this.props.text, right? Or I'm also going to run through those lifecycle methods that might be affected in this updating phase because the props have changed. And maybe these lifecycle methods do use the props to do something, right? That's all up to us and how we want to write our code. The props have changed. I'm going to start going through my update cycle. The update cycle could also be triggered if this.setState gets called inside of our component. So we don't actually call setState inside of our lifecycles class because we don't have state, right? Which is fine. But if we look at our app component, we do have state. And we do call setState whenever we click either of these buttons. So whenever we click one of these buttons, React re-renders this component as well. It goes through the update phase of our app component as well. Because there might be things inside of our component that depends on the state to determine what they need to do, including our render. If, for example, we were displaying this.state.text inside of our component ourselves, the component needs to decide, oh, okay, I should probably re-render because there's a chance that this component is rendering something on the state. So that's why it does it. It's like, okay, the component state has changed as well. Let's also run through our update phase for our component. And then finally, we can also force an update by calling this.forceUpdate inside of our component anywhere. This forces the component to update everything. It just forces it to go through the update phase. But inside of the update phase, it just goes through these following methods. So just like our mount, right? It also goes through the render again. Because new props comes in or new state comes in, React has to go through its process of deciding, oh, what in my component has changed? And then it's going to update the DOM, right? So it's going to update the DOM with the changes that are required in that component. Again, we're not remounting the component. We're just making the change to that piece of the component where it's affected. And then it calls component.update. Similar to component.mount, it's the lifecycle method that gets called after the updates have been made to the DOM. And here, we can see this when we click update text, right? We see it calls render, and then it calls our component.update. Now, one thing I want us to look at is actually this lifecycle method. So I'm just going to put it in here. It's should component update. Should component update is a lifecycle method that determines whether or not this whole chain needs to happen. And it actually exists between these things that would trigger this updating phase to happen and the following lifecycle methods to get triggered. Should component update actually sits right here. And what it does is it gets the props and then the next state, right? So it gets, when props change, they come in as a parameter. Or when state changes, it also comes in as a parameter. And what happens is that based on the props, the new props that are coming in, or the new state after we've called set state, we can determine whether or not we want to go through these other lifecycle methods, including actually re-rendering our component, right? Because if we don't want to re-render our component, we don't have to. And how we would do this is actually if we looked at our app.js. So for example, whenever set state gets called, we know that what gets happened is our render call gets called, right, in our component. So whenever we call set state, we're actually re-rendering this whole app.js component, which actually ends up re-rendering the lifecycles component. Even if we were not passing this text in, this component, because it's a child of our app.js, gets re-rendered. I can actually show you, if I get rid of this prop, so we're no longer passing the prop into our lifecycles method, even though I click update text, you will see that our render method and then component did update is getting called from a lifecycles component. This is because of how React's node tree works. React knows that inside of this component, any of the children might need to be re-rendered because it's just going to assume that everything in the render is affected, possibly by the state changing or new props coming into this component, right? So whenever a component gets updated, re-rendered, all the children also get re-rendered. And this happens whenever, again, as we saw, props change or set state gets called or force update gets called inside of the component. Now, the reason this is important is because let's say we called set state on a property that our lifecycle method doesn't care about. Let's say, for example, we had another state property, I don't know, message, right? And then this value we used somewhere else inside of this component. We don't pass it into lifecycles as a prop. We just use it somewhere else. Well, if set state gets called that updates this message, we just saw that it's going to force our component to update, right? And our component, if the state.txt hasn't changed, why do we need to re-render our lifecycles component? That's a waste of processing power. It's slowing down our browser. So what we could do here is it allows us to selectively hijack and not go through that re-render, right? We don't have to re-render our component. And here we can see we do that by what gets returned as a Boolean value from should component update. If we return true, then our component will update. It will continue, it will go through, right, the cycles, and it will run through that component did update. And here we actually see us logging the next props that we're getting, right? So whenever we clicked update text, we see that the text is coming through, right? That's the property, the new text property that we're getting. But if we return false, what happens is that it doesn't even go through any of those lifecycle methods except for should component update. Because when we return false, we're saying, I don't want my components to re-render. And the reason we would do this is, for example, if we were to check the next props that we're getting, if we see that the string value for our text has not changed, then we don't care to update them. We don't need to. There's no reason for us to do that. And here we will see that if we click update text, we're getting this call, our should component update. But because we're returning false, it does not go through the next cycle methods that need to happen inside of our updating phase. And the reason we would do this, as I mentioned, is because maybe we don't want to re-render because our text didn't change. And we can actually force this to happen if inside of our button click, instead of appending hello, we just keep the text as what it is. But because we're calling set state, we're forcing the state to change. And because we're forcing the state to change, we're forcing React to re-render our component. So now, inside of our lifecycle methods, what we can do is here we can actually say, we want to return, instead of false, we want to return if nextprops.text does not equal this.props.text. So if the current text is the same as the next props text, then don't re-render because there's no point to, right? We don't need to re-render our component because our props have not changed. So now we'll see if we click update text, it doesn't update. But if we go back and we say that, okay, now the text is changing, well, then our component will update accordingly. So this is mainly just for performance. If the properties coming in are not different than the props that we already have, then there's no reason to re-render. Now, understanding this update phase is so fundamental to us becoming better React developers because much of how code is structured and how the architecture for React is written is based around this update phase. Because this is fundamentally what the React library does for us. This is why we write components. This is why we break our code up the way it does. Because this update phase is how React makes our lives easier for us whenever it updates the DOM. Based on new properties coming in, based on us calling setState or forcing updates inside of our components, this triggers a chain reaction of, for example, our app component updating also its children, not only re-rendering itself, but re-rendering any child components it has. And then those child components also update. But that's the thing, if we trigger big updates like this, there may not be a need to even update these components if, as we saw, the props do not actually change. If the props don't change, nothing about this component needs to update. So leveraging the lifecycle methods will allow us to possibly improve the performance of our application, but also give us a better idea of when we should do what with our components. Now, of course, we're going to practice more and more with writing our components, building React applications, but just thinking and keeping this in the back of your mind as we code will help you better understand why we structure the code the way that it is. This will all make more and more sense the more you code in React. Now, I know this was a bit of a longer lesson, but now that we understand what the update phase, let's move on to the last phase, the unmounting phase.